scientists deciding to leave the university to start up companies. And so as a result, that culture of being a doctor or being a scientist has really kind of come with the industry. And so typically what happens is that you find that a lot of folks that are in biotech, even though they might not be practicing scientists, they work in the marketing department or they work in, the finance department or business development or something like that. They have a science background, but it doesn't mean that you need it to do those things. The typical pathway, I'll just kind of describe my own, is that, so I started off as a scientist. I, had a biochemistry degree, a master's degree in biochemistry, and then became an attorney. And after I got my law degree, I worked in academic licensing, worked for the Mayo Clinic and then the Dana-Farber Cancer Institute. And then went over to industry, worked for Millennium, Genzyme, a couple other companies. And my area of specialty was intellectual property licensing and patents, right? And so with that kind of got me into the business development, corporate development group. But there's no, it's not like I went for a degree in school for biotech, and that's how I got my job. It's just, your life experiences will kind of wend their way, and at some point, you'll find yourself kind of in there. And so my advice is that, if you have the time and the energy to do it, you should try to couple your social science degree, meaning your MBA or maybe it's a public health degree or something like that, with the hard science. So maybe it could be getting a degree in like a master's degree in biochemistry or something like that, because that's what's really going to make you more marketable. Otherwise, I think trying to get into the biotech industry with a general business degree, you'll do it. You just have to be a little bit more diligent, and you really need to kind of convey your skill sets. And I think in the end, really, it's personality driven, because you'll find that if you have to work with somebody for 10, 12, 13 hours a day, a lot of people will go on the fact that you have a good personality. So it's great that you have the finance degree or the marketing degree, but can I work with you? And I think that's true in every sector. But biotech, it's a very intense sector. Because it's so startup driven, you have people who basically work, 15, 16, 17 hours a day, every day, because they're looking to do fundraising, they're going to venture capitalists, they're making the pitch, they're trying to collect money to start a company and get it up off the ground. And so people tend to be very intense and they work very hard. So if you're going to have to work with people like that, personality will matter. And what else would I say? I think that, biotech, like I said, it's out of all the industries that are out there, it's the one, let's say, for the next 50 years is going to be stable. Because, and what I mean by that is that, right now, the next 10 years, we have an aging baby boom population that's now coming into its like sixth decade. So the strain on the healthcare industry is going to be huge. And so the question becomes, how do you get medical care and the medicines that you need to treat an aging population that is going to be, over the next 20 years, 30 years, it's going to be 60, 70, 80-year-old people. And on top of that, because of the longevity of the lifespan, and because you are living longer, you require more medical care. So you're going to be, you'll find that people will need cardiac drugs, lipid-altering drugs like statins, things like that, Lipitor. And so this is really going to kind of put a big push on the industry to keep innovative and keep making new drugs, which is why I said, for the next 30, 40, 50 years, it's a solid industry, and it'll be a growth industry, unlike some of the things in the past, like textiles that have, we don't make anything here anymore. But biotech will be here. So I'll stop there. If you have any questions, I'm happy to answer anything you have. Any questions you have. And like I said, we'll make it conversational and free flow. Yes?
How do you see the possibility of nationalized healthcare impacting the drug companies and hence biotech?
Yeah, that's an awesome question. so there's a lot of talk about that. And so nationalized healthcare, this is my opinion, I'm not speaking on behalf of the Mass Biotech Council or anything, but my view is that what'll happen with nationalized healthcare is that, the government will have an inordinate amount of power, purchasing power, negotiating power over the drug companies. And so what'll happen is that because I don't think we'll ever get to universal health care, but we'll get pretty substantially close to it. And so the government becomes the biggest buyer of medicines. And because it is the biggest buyer, it has so much negotiating leverage against the drug companies that it will actually demand lower drug prices. Okay? So now what will happen is that there's this downward push on pricing. Okay? If you look at innovation, 20% of the prescription drugs fuel innovation. Yeah, fuel innovation. And the balance of those drugs, the generics, don't. Because as I mentioned before, the margins are so thin on generics that you don't have enough capital to support innovation. The average cost to bring a drug to market from the time of discovery to 10 to 12 years later when it's ready for launch is close to $800 million. And there's some numbers that say it's as high as $1.2 billion, others that go the other direction say 600 million, depending on who you talk to, but 800 is right in the middle. So what you're doing is that you're actually, for an $800 million expense, when you need $1 billion a year drug to cover the cost of that $800 million. That $800 million is being driven by the cost of failure. And what I mean by that is, it's a 1 in 10,000 chance to go from, identifying a gene to coming up with a drug. So 1 in 10,000. And so you start out with 10,000 molecules, only one of them makes it to the market. All along the way, you're filtering the whole process, right? So you start out with 10,000 molecules, 5,000 molecules, you come down to 100 molecules, 50, 25, you get down to 1. By the time you go to that, you spend $800 million. So the only way to get that back is to have that $1 billion a year drug like Lipitor. And so, as I was saying, as the drugs go down to generics and the margins get really thin, you can't support that kind of expense. So if 20% of those prescription drugs are fueling innovation, and now you bring universal health care and you drive the cost of drugs down, then you start to stifle innovation on the back end, right? And so my prediction, I think, is that if that happens, I think you'll probably start to see, the pipelines, a lot of these pharma companies and biotech companies start to freeze up because of that. And so, like all things, there's a lot of lobbying that's going on right now to make sure that it doesn't become too restrictive. Yes?
But can that be fixed by increasing funding for R&D?
So increased funding of R&D.
So if you just increased NIH funding, wouldn't that help maintain innovation?
So it'll help you maintain innovation, but think of it as kind of like your backyard hose, where you turn the faucet on one end and you stick a cork in the other. And so if no matter how much you turn the spigot on the front end, which you want to call money for innovation, if you don't have a reasonable means to make money on the back end, you're just sticking a cork in the whole thing. And so the whole thing just gets kind of mucked up. So you have to kind of have free flow on both ends. So even if we do increase funding, through the NIH, which we all agree is a great thing to do because you need to have that innovation, it has to be a comprehensive solution, which means that you can't just do one without the other. Yes.
And most of the cost that present you are spending in the industry is for the research or the development of the farm.
Okay, another good question. Tying back to what she asked about innovation, right? So innovation is very costly. The government subsidizes it heavily through government grants, and so at one end there's a lot of